Sanibonani bafethu. I hope ni right lapho. Need you to grab the things that you need. Grab your pencil, your ruler, and your mara not now calculator ungasayithathi. And yeah, make sure ukuthi uhleli grand. Now this is Euclidean, right? Um, bakhona abayimbi bafuna ukuthi ngiyenze, and then I was like, okay, maybe just prepare and then maybe do it. And yeah, so what I've planned ukuthi I wanted firstly before I do a question paper, maybe just give like an understanding like my basics because I feel like if we can master the basics, then we'll see everything ngathi izoba lula kancane, right? So yeah, so these are the five most important terminologies that I feel are very important, especially in Euclidean, right? So yeah, without more isikhathi, please make sure ukuthi nje uhleli phezu kwetafula lakho sasebenza ke manje. Okay. Now we have what we call a radius. Right? What is a radius? A radius, it is a line drawn from the center to a point on the circumference. As you can see now, line yethu lana ngiyenze ngobuyellow. Ne? Maybe just scroll down, okay? Ngiyenze ngobuyellow, right? So you can see that it is a point from the center to a point on the circumference. Then we have what we call a diameter. Now, omunye yazi ukuthi awu maye yini that thing? Now relax. A diameter, it is a line that joins 2 points on the circumference passing through the center, right? For example, here, Ebony diameter is the line that is done in black. So what is it? It is a line that joins 2 points, right? You can see there is that point here and there's that point over there. It is a line that joins 2 points on the circumference, but now that line, it passes through what? It passes through the center. Ne? Remember, a radius, it is a line that is drawn from the center to the circumference. Then we have a diameter. It is a line that is what? It is a line that joins 2 points on the circumference, passing through the center. Siyadlula ke lapho. We move on to secant. Now, what is a secant? A secant, it is a line that cuts through 2 points on the circumference of the circle. Now, a lot of people tend to confuse secant chord, right? Now, one thing you need to understand is that yona secant, it is a line that joins those 2 points, but yona, what does it do? It cuts through. This is the most important. It cuts through, right? Then we move on to chord. Now, what is a chord? A chord, it is a line that joins 2 points on the circumference, right? But yona, it does not pass through the center. All right? It does not pass through the center. What does a secant does? A secant, it is a line that cuts through 2 points, right? Meaning, for example, it's going to do this. Yona, it cuts through. Ne? A chord, yona, it's just iphelela lapho kule circumference, right? So, and remember, a chord, it does not pass through what? Through the center. The diameter, it passes through the center. The secant, it does not pass through the center. What does it do? It cuts through the circumference, the 2 points on the circumference of the circle. I hope you understood that one. And then guess we go tangent. Now, what is a tangent? A tangent, it is a line drawn from a point outside the circumference which touches the circle at one point, right? And then now it's called the point of contact. That is very important. Sometimes, especially with theorem number 7, give you a statement and then but at the point of contact, I'm told you need to know, okay, there's a tangent somewhere, somehow. And then a key one also, you need to know that it is always perpendicular to the radius. Now, can you see that this line over here, let me take a different color, let me use a different color. Can you see that now that this line over here, it is also a radius because it is a line from the center to a point on the circumference. And then now I want you to, the most important thing that you need to know about your radius is that they are equal in length, right? Even this is a radius. This is a radius. And all together, we call them what? We call them radii, right? We call them radii or radii. Some other people, they prefer radii. Some other people, they prefer radii. So whatever you call it, right? So, tangent, what you need to know is that, what do they say? They say it is a line drawn from a point outside the circumference and it only touches the circle at only one point. So immediately this drawing, it is not accurate, but usually tangent, it touches the moment it touches the circumference, right? Because it only touches that at one point. And then what they also say that it is always perpendicular to the radius. So since this line, it is our radius, and if it's something is perpendicular, which means there is what? There is a 90 degrees angle. So yeah, so these are the important things that you really must know. Yeah, one, it is. So now you can pause the video just in order to practice, what is going to be terminology, but then we're going to move on to our next part of the video. Now, we are under Theorem 1, right? We're going to start with Theorem 1. Now, what does Theorem 1 states? Now, Theorem 1 states that the line drawn from the center, perpendicular to the chord, what does it do? It bisects the chord. Now, the word bisects, the word bisect means that it cuts it into two equal halves. Now, these theorems, you need to know them by head and you must know them by heart. Noma nje ngafika ngikuvuse kusasa ngithi mfethu awungayi theorem 1. You need to be able to give me with, okay, the line drawn from the center perpendicular to the chord bisects the chord. Like it must be your daily, I don't know what's a daily bread, but something that you must know. So you need to like practice them, just in jail, as if you're doing AMA definitions. The way you do definitions in life science, you need to know them by heart. Okay, so now the line drawn from the center perpendicular to the chord. Now, let us look at this drawing over here. We can see that OD, it is the line drawn from the center, right? And can you see that 8B, it is our chord. Remember, what is our chord? Our chord, it is the line that joins what? 2 points. Can you see A is a point, B is a point. It joins 2 points, right, on the circumference without passing through the center, meaning it does not pass at what? At O. If there was a line that passes at O, we were going to call that what? A diameter, right? So now the line drawn from the center perpendicular to the what? To the chord, which means it forms what? A 90-degree angle, which means we're going to have D1 and D2, right? And then now it bisects the chord. So immediately, if it bisects AB, which is our chord, which means now it's going to cut it into 2 equal halves, which means that side will be equals to that side. And then now we are required to prove this theorem. We are required to prove now this theorem. Now we are required to prove that AD is equals to DB. Let us look at our AD. We are required to prove that this side is equals to that side. Now, first thing, guys, before you're about to solve or you're about to prove a theorem, first things first, construction, right? we need to do our construction. So now what are we going to say? So we're gonna go under construction. There's our diagram there. So say construction game. So now construction. So our construction, we need to say, let me choose the right color. Okay, we need to join OA and OB. That is our first step. We need to join OA and we need to join OB, right? Now that's what we're going to be doing khona manje. So join again manje lana. So this is what, okay, and then this is what is happening. All right, so now can you see ukuthi now there are two triangles that are being formed? Name, we have triangle A. Okay guys, this is a D, ne? Ish. This is a D. We have triangle ADO and we have triangle BDO, right? So now in theorem 1, basically, ne, when we prove this theorem, it's sort of like we are doing congruency. Ne? I don't want to say we are using congruence, but something similar to congruency, right? Where you are doing your side, angle side, your side, right hypotenuse side, if you still remember those. So now, in this case, we are comparing two angles. Remember, what are we required to prove? That AD is equals to DB. Then now, first things first. Now, between the two triangles, name. Okay, don't forget that OA, since there's a 90-degree angle, and you must know that the side opposite the 90-degree angle, we always call it a what? A hypotenuse. Yeah? Okay, so can you see that in these two triangles we have a common side, which is OD, right? I'm giving you some of the answers here, which is equals to OD. Yeah? Then now, the first thing that we are required to prove now. So we're required to prove that, can you see that OA is equals to OB, right? Our reason will be radii. Tinishang is small letter. It will be radii. Can you see that? Remember, you need to go back to your terminology. What is a radius? A radius, it is a line drawn from the center, right, to a point on the what? On the circumference. Can you see that? Can you see that OA and OP, it is what? It is a radius. Now, there's a difference between OD and OA. OA, yona, it doesn't come to a point on the circumference. What it does, it only bisects AD, right? If it was extended until, let's say, a point on the circumference, and then we called it point E, then we would also consider it as a what? As a radius, right? But only there are two only radius, right? So we have OA and we have OB. So you're gonna say OA is equals to OB, because radii, right? And then now let us look back at our diagram. What else do you see there, right? Can you see that OD, it is our what? OD, it is our common side, right? So OD, it is our common side. So OD is equals to OD. Reason is cause common side. Okay, now remember, we are left with one thing to prove. Not necessarily one thing, but okay. And then what else do you notice about this triangle? Can you see that? Now, this is theorem number 1. Let us read. The line drawn from the center. perpendicular to the chord. Now I'm going to highlight this, perpendicular to the chord. Remember, if you heard a word like perpendicular, it means there's what? 90 degrees. So can you see that my angle D1 is equals to my angle D2, right? They're both 90 degrees. Why? We were already given that from the statement, right? Because they say that the line drawn from the center, it is perpendicular to the chord. So we were already given that from the statement itself, right? So what are we going to say? We're going to say angle D1. So we're going to say maybe I'm going to say angle D1. Then the reason it is because we were given. I don't know why it's in small. Okay. Because we are given. We are given. Okay. Right? And then can you see good now we're going to have, so we have proven the most common side. We have proven that OD, this common side. We have proven that OA is equals to OB, reason being it's because of radii or radii. And then we can see that angle D1 is equals to the same as angle D2. So here in this case, we are checking what is similar in triangle ADO and in triangle BDO, right? So in theorem 1, when you're proving, we're looking what are the things that are similar, right? Because we are required to prove AD and which is equals to DP. Now, most people had this question, now, can't we say when you're proving AD is equals to DB? Then the answer is no, guys. But if you're required to prove something, you cannot write that as your answer, or like, yeah, you cannot, like, it's kufana nokuthi bathi solve for x, right? And then the answer yakho, it is x instead of x is equals to, right? So now we cannot, when you're proving and they ask you to prove 8 is equals to dp, yes, they do say that it bisects the chord. So necessarily here, we are trying to prove the statement that says that the line drawn from the center, it is what? It is perpendicular to the chord, and it what? It bisects the chord. So basically, we're trying to say what? Okay, does it actually bisect the chord? Does it actually cut it into two? I don't know if I'm making sense. Yeah? So we're checking. We are proving what? Okay, because now this is in maths, you can't just make a rule without proving it, right? So here we are just proving it. How did they get it bisects the chord? So this is the step that we're actually doing. All right, and then we are not done. Right? We are not done. So what I'd like to advise you with, we just do this, right? Can you see that OA and OP, it is a side, and yes, it is also a hypotenuse, right? So we're going to do this. So remember, we had your side angle side, we had your right hypotenuse side, we had the right hypotenuse side, you had your angle, angle. So this is what we're basically doing over here. So now, since it is a 90-degree triangle, which means now the radii, it is opposite the right angle, which makes it to be a what? A hypotenuse side. Yeah? And OD is equals to OD because what? It is a common side. And angle D1 is equals to angle D2. And those angles are right angles, right? Which makes it, so Lana, I'm going to make it to be R. So I'm gonna look at what I have over here. Oh, this is side angle side. Right. So can you see what you are picking up this right hypotenuse side, which means now when you're about to conclude, this is what you're going to say. You're going to say, therefore, I don't have it therefore, yeah, but I'm going to say, therefore, triangle, maybe do this, and then our reason will be right hypotenuse will be hypotenuse side. And then if now, right, if triangle OAD is equals to triangle OBD, right, if now this triangle is equals to that triangle, surely now this side will be equals to that side, right? Because like OA is the same, OA is equals to OB, OD is equals to OT, there's a common side, the angles are the same, and then surely what makes AD not to be equals to DB, right? So now we can say, well, okay, we have seen that most things are common, right? Therefore, which makes it okay, and then now we can say that surely now AB is equals to DB. What is the reason? The reason is that triangle OAD is equals to OBD, right? Triangle OAB is equals to triangle OBD. Because now, so one thing I can advise ukuthi mawuprova le theorem lena ne, always start with, like, always check, you need to identify your diagram, right? Always check with, okay, do I have radii, right? Which one am I, radi or radii? Do I have a common side? Are the angles the same, right? So you need to know these things: your side angle side, right hypotenuse side, your angle. Like we did these things in grade 10, I think. Yes. So yeah. So this is how you have to prove your theorem. And then now you need to note that when using this theorem to solve riders, we use line from the center perpendicular to the chord. Now, what is a rider? Like, ama riders are those questions zakhona, but that's when we can use line from the center perpendicular to the chord. But when we are required to prove all of this, you are not supposed to use this reason. Ne? I really hope you guys really understood everything. But before we end the video, I want us to again to remind yourself, what does Theorem 1 state? Theorem 1 states that the line drawn from the center perpendicular to the chord, what does it do? It bisects the chord. Ne? Another way, let me give you a trick on how I master these things. Now, this trick, you need to come with a pen and a paper, like a clean paper, right? Draw your full circle. Now, we're going to state theorem 1 at the same time we're going to draw, right? Now, this way, it's going to stay in your brain. So now, let us start. The line drawn from the center, right? So the first thing that you need to do, you're going to start drawing your chord. You're drawing your chord, and then you start from your center. You begin to say the line from the center, right? Perpendicular to the what? Perpendicular. Okay. Perpendicular to the chord, right? What does it do? It bisects the chord, meaning it's going to be equal. And then that's when you can draw your triangle and stuff like that. This is a trick that I usually do in order to remember it. So what do you start? You start by drawing your chord, then you start by saying, without looking at the statement, you begin and say the line from the center perpendicular to the chord. And what does it do? Remember, bisects mean it cuts into equal half. It bisects the chord, right? Then now you know it's okay. This side has to be equal to that side. And then OA, like this side is going to be your radii, right? Yeah, I don't want this video to be long, but this is what is happening. So I'm going to click, I don't want this video to be long, so I'm going to do an example now based on this theorem only.